The next algorithm we are going to talk about is the repetitive nearest neighbor algorithm. Now, this has a variety of steps. Step 1 states that we start at X. We start at a vertex and apply the nearest neighbor algorithm. Then what we do is in step 2, we repeat the process using each of the other vertices. So if you look at this model here, we have 4 different vertices. So in essence, we're going to do the nearest neighbor algorithm starting at A. We will get an answer, and then we will start over. We'll do it a second time, except this time we'll do the nearest neighbor algorithm starting at B. We'll get an answer, and then we'll start over a third time, and we'll do the nearest neighbor algorithm starting at vertex C. We will arrive at an answer, and then lastly, we will do the nearest neighbor algorithm one more time starting at vertex D. Now, we will have 4 different Hamilton circuits at that point. And what step 3 says, of all the circuits obtained, use the cheapest. So whichever one has the smallest value, that is going to be the Hamilton circuit that we are going to use with the repetitive nearest neighbor algorithm. So of the nearest neighbor circuits obtained, keep the best one. Step 5 states that if there is a designated starting vertex, rewrite the circuit using the vertex as the reference point. And that's what's going to happen with this example. What we're going to do is we're actually going to, at the end of this problem, when we do this using the repetitive nearest neighbor algorithm, our reference point is for a salesman that lives in Denver. So that's what we have to remember at the end. We want to make sure whatever is the cheapest circuit that we find, we need to rewrite it for our salesperson living in Denver. If the cheapest one is already starting at and ending in Denver, then we don't, D for Denver, then we don't really have to do anything. But if the cheapest one is starting and ending at A, then what we're going to have to do is rewrite that circuit so that it starts and ends at D. So let's go ahead and get started. The first nearest neighbor algorithm is we're going to use it starting at A, and I just put a little star right here. I like to do my little pictures. So we're starting at A. We're just going to apply the nearest neighbor algorithm. So it's cheapest to go to D. So it's going to go A, D. From D, we can either go to B or C. B is cheaper for 70. Oh, AD was 60. D we then go to B, and that's 70. Now it's clear that we have to go to vertex C. From B to C, that is 140. And we've been to every vertice, so now it is time to go home to A, which is 210. And the total amount for that Hamilton circuit is 480. Okay, that's it. First one done. Now we have to start completely over, except this time we're going to apply the nearest neighbor algorithm starting at B. So here we are starting at B. Where is it least expensive to travel to? Well, it's at least expensive to travel to D. So from B to D, that is 70. From D, we have 2 options. We can go to C or we can go to A. And it is least expensive to go to A. It's 60. Now from A, we have to go to C. And from A to C, that is 210. And then from C, it's time to go home back to B. And from B to C, that is 140. Now the total cost of this, if you add all those numbers up, is 480. So we have the nearest neighbor starting at A, we have the nearest neighbor starting at B. See, this is getting a little repetitive. That's why it's called the repetitive nearest neighbor algorithm. And now we're going to do the same thing and start at C. So C, we can go to B, to A, or to D. It is cheapest to go to B for 140. So from C to B, that is 140. We have 2 options, either D or A. We're going to go to the least expensive, which in this case would be D. And it's 70. from D, we've been to every vertex except A, so we have to go to A, and that is 60. And now it's time to go home. Back to C, and that is 210. The total cost of this is 480. And that is the nearest neighbor algorithm starting at C. Now it's time for our last one, starting at D. So starting at D, where it is the least expensive would be A. So we're going to go from D to A. That is 60. Now from A, it is more. We have two options, B or C. It's least expensive to go to B for 200. Now we have to go to C. That is 140. And then have to go home to D for 160 for a total cost of 560. Now we have all of the nearest neighbor circuits obtained, one starting at A, one starting at B, one starting at C, and one starting at D. What we want to do is just keep the best one. And this is kind of interesting because actually there's three that are the least expensive at 480, and if you look at the pictures, they're exactly the same circuit. So this is going to be the one that we are going to choose. However, at the end it says if there's a designated starting vertex, rewrite the circuit using the vertex as the reference point. So we do have a designated vertex. We are writing this for a salesperson that lives in Denver. So I'm just going to pick one of these and write it for the person living in Denver. So we're going to start at D. This is one of the least, and let's go to B first. From B, we can go to C, and then to A, and then back to D. Or we could do the mirror image, which would just be D, A, C, B, D, or D, A, C, B, D, D, A, C, B, D. Also, if you look here, D, B, C, A, and then back to A to D. So you can rewrite the circuit just by looking at these letters as well. And that has a weight of 480. And that is the Hamilton circuit you would find if you're using the repetitive nearest neighbor algorithm.